For the last two examples in this lesson, we will discuss a technique called trigonometric substitution. This technique is used in Calc 2 for computing certain integrals. The idea is that if you have a complicated expression of a certain type, that if you replace the variable in that expression by a trig function, then the expression after simplifying becomes a lot easier to handle and to deal with. In Calc 2, you are going to be required to memorize what type of trig substitution you're going to make. In this class, of course, I'll just tell you, what the homework will tell you, and your job is just going to be to simplify. Okay, so suppose I have this algebraic expression, and we want to make this simpler by making a substitution, a trigonometric substitution. And in this particular problem, I tell you the trig substitution that you're going to make is that x equals 2 tangent of theta, meaning that you're going to replace the x with 2 tangent of theta. After simplifying, we're going to get an expression in terms of the angle theta. This condition right here, theta is between 0 and pi over 2, is just telling you that the angle is in the first quadrant, so that things are positive. All right, so let's just do it. This is actually not hard. So what do you get? So x equals 2 tangent of theta is what they're telling us. Okay, so we're going to replace the x with this, with 2 tangent of theta. So this is going to become 4 plus, now the x is 2 tangent of theta squared. Now squaring, this is going to become 4 plus 4 tangent squared of theta. So you square the 2 and you square the tangent. Now note that 4 is repeated, so it's a common factor, so you can factor it out and say this is 4, 1 plus tangent squared. Okay, what happens now is that this is going to be one of the trigonometric Pythagorean identities, and 1 plus tangent squared, it is secant squared. So then this becomes square root of 4 secant squared. Okay, and now you can take the square root of this. The square root of 4 is 2, and the square root of secant squared is secant of theta. Normally, you're supposed to put absolute values, but because they're telling us that theta is in the first quadrant, we know that all the trigonometric functions are positive in the first quadrant, so you don't really need absolute values. And that's it. You see? We're done. That's how it simplifies. Okay, let's do another one. If you got that, maybe you should try this one. It says, use the substitution x over 3 equals sine of theta to rewrite this expression. So give it a shot. Okay, assuming that you tried it, let's see if you get the same thing as I do. All right. X over 3 equals sine of theta. Well, multiplying by 3 both sides, this means that x equals 3 sine of theta. And I'm going to use that to put it in here. So x equals 3 sine of theta, put it in there. So let's see what we get. We get square root of 36 minus 4x squared. All right, now you get 4. X is 3 sine of theta. And then you have the square. Okay, now squaring this one, 3 squared is 9, and then sine squared. Now 4 times 9 is 36, so this is 36 minus 36 sine squared. Okay, now you see the 36 is repeated, it's a common factor, so factor it out. So this is 36, 1 minus sine squared of theta. You should be able to simplify that using a trig Pythagorean identity. And indeed, this is cosine squared. So this is going to become 36 cosine squared of theta. And lastly, square root of 36 is 6. Square root of cosine squared is cosine. And again, you're supposed to put plus or minus or absolute value, but because theta is in the first quadrant, that's why that condition is always put there. This is going to be positive, so you don't really need plus or minus or absolute value or anything like that. So that's it. This is a simplification. Okay, so the idea in calculus would be that integrating, finding the integral of this is a lot easier than finding the integral of that. Okay.